Welcome back. Our last topic in acids and bases is buffers. And what do you think of when you think of buffers? You think of maybe somebody asking a buffer between two people who are angry at each other. They're that person in the middle that prevents those two people from hurting each other. So there's a kind of this protective thing about a buffer. And it turns out a buffer in solution is the same kind of thing. It's very protective. A buffer is a solution that resists changes to pH. It's a solution that resists changes to pH. Specifically, people will add on to that when you add a small amount of strong acid or strong base. But I like to leave it there a little more simple. It's just a solution that resists changes to pH. What do we mean by that? Well, if we take pure water, right, just some water in there, and we go ahead and we add, let's make it a different color, we add some H plus into that water. If we add some H plus into that water, what's going to happen? That H plus is going to float around, right? And what's going to happen to the pH? As concentration of H plus goes up, as we have more and more H plus, our pH is going to go down. Right? So in that system, as we added H plus, our pH went down, which is fine. It's just what it's supposed to do. We can draw the same kind of system here, where we have just pure water. And in this case, we're going to add some OH minus. What's going to happen is we add OH minus. Well, that OH minus is going to start floating around. And you're like, well, does that change the pH? The pH is only dependent on the H plus concentration. But remember our equation that H plus times OH minus is 10 to the minus 14th? That says that they're linked. As OH minus goes up, our H plus has to be going down simultaneously. And as our H plus concentration goes down, our stuff becomes more basic and our pH goes up. So as we add H plus to pure water, OH minus to pure water, our pH goes up. But what if that wasn't a good thing? What if we wanted to have a situation where we could add acid or base and the pH wouldn't change much? And why would you want to do that? Well, it turns out in our bloodstream, the pH range where we're healthy is actually very, 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 very narrow. Depending on what source you use, it's somewhere between around 7.36 to 7.42 is the valid range of pHs that our blood can be at and be physiologically healthy. And you're like, okay, well, it's not too bad. Why is that a problem? Well, if you like to drink soda, soda is very acidic, especially Coke. Very, very acidic. And you can do a quick calculation that says if you drank 3 drops, not like 3 cans, 3 drops, like you took a dropper, took 3 little drops of Coke, that's enough acid to knock your bloodstream out of equilibrium and cause you to have physical problems. And if by the time you drink a whole Coke, or you go to 7-Eleven, you buy that giant super big gulp 12-gallon thing, you drink that, you're dead. I mean, there's just no way to recover from that because you have such a narrow range that our bloodstream works. But somehow we don't die when we drink Coke. And why is that? It's because there's this cool thing in our body, in our bloodstream, and in other parts of our body called a buffer. And that buffer resists changes to pH. How does it do it? It does it by containing 2 things. A buffer contains a weak acid and its conjugate. Most people, just as a generic way, will call the weak acid HA and the conjugate A minus. A could be, nitrite, so you could have nitrous acid. It could be acetate, acetic acid. And then the A minus is the conjugate, which would be the nitrite ion or the acetate ion. I'm going to use HA and A minus just to be a little more generic here. So the first thing I'm going to put in my solution here is a bunch of HA and A minus. I'm not just going to have an empty solution of just water when I put it in. Now I'm still going to toss in a bunch of H plus, and it's going to float around that solution and see what's in there. Now, H plus floats around, it sees HA and says hi, and HA is like, I'm good, hi, nice to see you, kind of like social distancing. But H plus and A minus, they say hi to each other, and H plus says, well, how you doing? I'm positively charged. A minus says, well, I'm negatively charged, and I actually really like like hydrogen ions because I am a strong conjugate base, right? HA is a weak acid. That means A minus is a strong conjugate base. And these two are actually going to get together. And the H plus and the A minus are going to react to make HA. And so I put in some H plus, but it reacted immediately with the A minus. And my H plus concentration basically didn't change in this beaker. And my pH doesn't change. Now, technically it changes a tiny bit, but not very much. Not near as much as when I added all this H plus and it was just sitting there floating around. How about OH minus? Got the same beaker here. I'm going to put my HA in there, my A minus, my HA, my A minus. I've got a bunch of it floating around in there. And I'm going to go ahead and add my OH minus in there. OH minus floats around. He sees some A minus. He's like, you're negative, I'm negative. See you. We don't want to be near each other. OH minus walks around and says HA. And it turns out that OH is a pretty strong bully. He is a strong, strong base. And so when he comes across an acid who's got an H to give it to him, he's going to take it whether the acid wants to give it away or not. So this OH is going to react with this HA, and they're going to make water and A minus. So those guys end up reacting. I have a little bit of A minus in there, but then I also just have some, water that I formed. So I added a bunch of OH, but that OH immediately reacted, and I've got no OH left. I've just got A minus and water, which I already had to begin with, and my pH doesn't change. And so I've got this really neat system where I can add H plus, I can add OH minus. Now I can't add infinite amounts because eventually if I keep reacting my HA, I'm going to run out of HA. And then as I add OH minus, it's going to change the pH. Same thing on the other side. But for small amounts, I can keep adding acid, My body, or this buffer system, can adjust to that. And that's a really neat thing. Very important physiologically, very important in chemistry as well if we want to control pHs of environments to make some specific types of chemistry happen. So what I want you to know about these buffers is, one, what is it made up of? What's the purpose of it? And I want you to be able to describe how it works. So I can ask you a question about how a buffer works. What happens when you add OH minus to a solution? You should be able to discuss that and talk about how it can react with the weak acid in there and essentially neutralize the OH minus. All right, that's our discussion of buffers. Thank you.